So the main idea for today is we're going to be talking about correspondence between points, segments, angles, and congruent statements. We need to understand this because otherwise when you start writing proofs, you will potentially lose points if you don't write out your triangle names correctly. Now in the past it's always been that the way you name a triangle didn't really matter. Just if you saw 3 points, you just put the 3 points down in any order. There is a little bit more to it now, and we're going to get to that. We're not starting off with that idea, but I want to just spell it out from the beginning that we're going to be identifying corresponding parts between congruent triangles, and it's really important that you understand the idea of how to find the corresponding parts. But this is what we did yesterday. This is just going to recap a bit on the triangle congruence theorems. If you weren't here yesterday, we learned them. It was just kind of a quick overview. We have 4 that are called side, 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 angle, side, angle, side, angle, 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 side. It's actually pretty straightforward, and the more we work with this, the more that these 4 congruence theorems are going to be really the easy part of the proof. At least I hope so. That should be the case. So what we're going to do is, on the front side of this worksheet, we had triangles that were given you needed to name, and you did that in class. You needed to decide which congruence theorem was being used. This is a little different. Now it's telling you which congruence theorem to use, but we don't have all the information we need. So the question is, what other piece of information is needed in order to use these theorems? Does that make sense? Okay, and I'm going to go through the first 2, I'll go through the first few of them with you. And then I'll just let you guys do the remainder of this worksheet. It should not take you long. We're not spending our whole class period on this. So the first one right here, it's asking us to use angle, side, angle. And that means we're looking for 2 angles with the side in between. If I look at the diagram, triangle TUD and triangle TUS, I can see they're showing me one of the angles is already congruent. And what else can we see in the diagram just right off the bat? Is there any other congruent element?
The middle line.
That middle line is congruent. Does anyone remember what we do for that?
X.
We put an X over it, which counts as a congruence mark. And it's our reminder when we get to proof that that's the reflexive property. All right, so now we've got 2 congruent elements already. We want to prove these 2 triangles are congruent. So what are we missing? Another angle. Which angles in particular will they be? No, not that. Remember, it's angle, side, angle. We already have one angle, one side. Now we know that the other angle has to make sure that side is trapped between it. Okay, it's going to be, the vertex will be at U, but we have to name it a little differently. So let's go ahead and draw them in real quick. So this angle right here has to be congruent to this angle. Do you guys agree? All right, now at this point, if they gave us that information, we'd say, yes, those are congruent because of angle, side, angle. All right, now what we want to do, we're not done yet. We need to actually write out what element is missing. So here's what I'm going to do off to the side. I drew it on the diagram, but now I need to show that the angle at the top, how would we name that angle? We can't just call it angle U. This goes back to what we were doing pretty much at the beginning of the year. When you name angles, how many points do you use? 3 points. So what would we name that angle? If it's the top one, it would be DUT is congruent to which angle? SUT. There you go. You can see that we're using the points that are given. U is the vertex. So DUT, that top angle, is going to be congruent to the bottom one, which is SUT. You guys remember naming angles? I'll tell you also as a preview, if you don't name angles correctly, you can lose points. So if this is something you struggle with, either talk to me to figure out how you can get better about it, or go back and review some of the stuff from the beginning of the year and maybe watch some videos online. But you need to know how to name angles correctly and segments. So much of proof is writing down the correct segments and angles. So, anyways, let's move on to the next one, and we're done with this. So now we've said this is the information. If we had it, then the angle-side-angle theorem would be met. We could prove these two triangles are congruent. The next one's asking us to prove with side-angle-side. Same situation as before, or similar one at least. We've got two angles that are congruent. We have that line in the middle. So I know that this is also reflexive property. So for side-angle-side to be met, what do we need to know? So one thing I remember from yesterday, hopefully you guys all remember from yesterday, side-angle-side means I've got two sides, and the angle has to be right in the middle between the two sides. So according to my diagram, I've already got the middle line is a congruent side. The right angle is one of my angles. So for this triangle on the right, I could say Vx, that angle with a vertex at x, and then over xk, that would make a side-angle-side, wouldn't it? Okay. And that means the corresponding side over here would have to be congruent. So that's the information I'm missing. If I look at just one of those triangles, I can see that there's a side-angle-side relationship. So now all I need to know, if I could prove this or if I could just have this information given to me somehow, I would need to know that segment xk is congruent to segment VW. Okay, so let's try the next two still working together as a class, and you guys can do the last four on your own. So we've got side-angle-side. These two are a little more straightforward. Side-angle-side, what's missing? Let's start with this. Is a side or an angle missing?
Side.
A side. So we've narrowed it down. Is it the side that's the hypotenuse or the side that's the leg?
Leg.
The leg. Okay, so let's just name those real quick. Someone tell me what the names of those two will be. Okay, CA and LJ. CA has to be congruent to LJ. Okay, and the last one we'll do as a class right here, angle side angle. What do we already know? Angle side what? What's already given as congruent? Angles or sides or a mix? Angles. So if it's angle side angle, what are we missing? The side. Which side are we talking about? There you go. The one in between, so DE and JK. So I'll go ahead and mark it right here with my congruency marks, but then I'll write the statement off to the side. What I still need to know is that DE is congruent to JK. Okay. So do those four make sense? Kind of what the task is? All right. So you've got these four right here. I'm going to put an answer key up in a minute, but just go ahead and go through these four. See if you can identify the missing information and write it off to the side. Actually write out. Don't just mark it on the diagram. Actually write out the angle or the segments that need to be congruent. All right, so here are the answers. And I just want to talk about the answers really quickly because I got this question as I was going around. The way that you name things does matter. And the way that it's going to affect you, most importantly, is making sure that you name segments correctly. It's 2 points for a segment, 3 points for an angle. Notice, well, anyways, we'll talk more about the angles here in a second. But there is something that we're going to talk about with the next handout that I give you guys in class today, where the way that you name your triangles is going to matter. And then basically naming the angles the right way. If you mix up, now I will tell you the way that I wrote this on the page. So RS is congruent to DQ. This is the best way of writing it. You could flip both of them around. It could be SR is congruent to QD. That's the best way of writing it. But as long as you have these 2 points, R and S defines one segment and D and Q defines the other, I'm not going to be a stickler for if you flip the order of it around. So anyways, and we'll talk about that on the next worksheet. So there is an ideal way of naming things. But the big one that's going to matter to you is making sure that when you name your angles, you name it correctly. And the other thing is when you name your triangles, you have to name those correctly. Okay, so any questions on this? All right. So hopefully you're getting more and more familiar with those 4 congruence criteria. That won't be like the most challenging part of this whole thing, so that should be something that in time you get really comfortable with. So let's go ahead now and look at this handout I'll come out with. All right, guys, I forgot that before we do this worksheet, so you're looking at that's well and good. I went a little bit out of order here. First thing, I asked you guys to have out a sheet of paper for some notes. This should not take us very long. We're just going to take a few notes on our 4 congruence criteria. This will be good for everybody, but especially if you weren't here yesterday. So we learned our 4 congruence criteria. Angle, angle, angle is not one of them. Neither is side, side angle. But we have 4 that we can use. So on your paper, if you're adding this to all your other angle facts and things like that, then you can just create a new section where all you need is name, diagram, and notes, 3 columns. And I'll go ahead and show you what the first line is going to look like. So if you've already got your table set up, you can start writing that down. All right, as far as these notes go in the end, it's just supposed to give you guys a little bit of kind of pointers to keep in mind as you're deciding which one to use. You can kind of use this sort of mental flow chart to say, how many sides do I know? If I know 3 sides, it has to be side, side, side. That one's pretty easy to remember and recognize in a diagram. Now we also have this one. I'm putting it up on the screen there. So the notes here, side, angle, side, say that this is the only triangle congruence theorem with 2 sides. 2 congruent sides given. So if that's the case, if there's 2 congruent sides, it has to be side, angle, side. Okay, the next one. Again, this is stuff that we learned yesterday. But we've got this. If it'll move on the screen up here. All right, that angle relationship right there. Angle, side, angle. Take a few notes on that one. And here in a second, I'll put up the last one. All right, and for those of you who are already finishing up, and I'll leave this up there for a while to make sure everyone can copy it. Oops, that's not what I wanted. I'll go ahead and add this. All right. Okay, guys, so make sure on this that you're noticing that these last 2, and we talked about this yesterday, but the last 2 both use 2 angles in one side. The difference being, if it's angle, side, angle, the congruent side must be between the 2 angles. So that second note there under the notes section is going to be kind of the key thing here. The side is not between the 2 angles for angle, angle, side. So if I was doing a problem and I was trying to figure out which congruence theorem I should use for a problem, here's just an example of what you could think. Do I know 3 sides? Yes or no? If I do, it's side, side, side. Okay, let's say we don't know 3 sides. We have 2 sides worth of information. Well, in that case, it'd be side, angle, side. There's only one choice if we have 2 sides that are congruent. All right, if we only have 1 side, so we'll go to that third scenario. This is where we have to make one extra choice. So basically, we just decide 3 2 or 1 sides that we know. if we get to that, there's only one side that's known, then we have to just figure out and distinguish between angle, side, angle, or angle, angle, side. So these two do get confused quite a bit, but just if you can think through it like this, according to what we have written down in the notes, you should be in pretty good shape. And I hope in the long run this is not a challenging thing. At the beginning you might have to think about it a little more, but by the time we get to the test, hopefully you're like, I know the difference between the 4 congruence theorems. All right, anyone still trying to write at this point? All right, so now I passed that paper out. Now let's actually look at that. And we're shifting gears a little bit. This is just notes to wrap up the congruence theorems. So now what we're going to do is we're going to talk about correspondence. And I mentioned at the beginning of class that's kind of the key idea for today. And we have to get this down before we can actually write a congruence proof. So that's what we're going to look at with this. And I think what I want to do real quick before we actually go through any of these problems, I want to just kind of give you guys an idea about what this is all about. So if I've got two triangles that are congruent, and let's say I already have a triangle congruent statement. So this is something that we'll be talking about quite a bit, what's called a triangle congruent statement. So let's say that triangle ABC is congruent to triangle DEF. The way that I write these names matters. Okay? So if triangle ABC is congruent to triangle DEF, I can't just decide to flip it around and say triangle ABC is congruent to triangle FED. It has to be in the right order. And the reason the order matters is because A, and I'll put A kind of in a random spot here. Let's say A is this corner on the left. A has to be the exact same corresponding point as the triangle on the other side, which would be D. All right? And if I call this point B in the left triangle, well, then this point over here has to be E. And therefore, C and F. So we're thinking about it in terms of transformations. Imagine I could translate this triangle on the left over until it maps onto the one on the right. And if I mapped it so that these two congruent triangles were sitting perfectly on top of each other, then A would land on top of D. And we can see that right here in the naming of it. A would map onto D. B would map onto E. And C would map onto F. All right? Again, imagine those triangles actually moving. So that idea, and this is why I was saying the way that you name your triangles in a triangle congruent statement does matter. So let's say this is the correct answer, and you wrote down for your answer that triangle ABC was congruent to triangle DFE. If you wrote that, and the answer was supposed to be the one at the top of the page, I would count that wrong, okay? So that would not be acceptable. Just a side note real quick. The other common thing I see happen wrong on tests, if you're supposed to write a triangle congruent statement, I know we haven't written a proof yet, but we'll write a bunch of these. If you're trying to write a triangle congruent statement saying that two triangles are congruent to each other, I get this mistake a lot where someone will write it correctly, ABC is congruent to DEF, and maybe they'll just write that. And that won't count because you need to show that it's triangles. Another thing people will do sometimes is they'll write angle. Now that's technically true, but if it's supposed to be a triangle congruent statement, you need to show that these triangles are congruent. So I'll count the angle symbol wrong also. So just make sure you're getting in good habits of writing it out fully and correctly. Okay, so let's go back to this. I just needed to kind of set up the foundations of everything. So on this worksheet, they already give us a congruent statement. It's not written out exactly the way that we just showed you, but we can show that. It says, if you look at number 1, it says triangle HYZ is congruent to triangle KLR. So I'm going to write that down. Triangle HYZ is congruent to triangle KLR. And from what we just talked about, which angle do you think angle L is congruent to? It's going to be congruent to angle Y. And the nice thing is that you can use the name to give you these answers. It's actually a lot easier going back to the congruent statement and comparing the points rather than looking at the triangle and trying to figure it out. And we'll see that in the next one. Segment LR is going to be congruent to what? YZ. And angle H is going to be congruent to angle K. And lastly, ZH is going to be congruent to what? RK. All right, pretty straightforward, pretty simple concept, but important to know that. All right, so the next one is basically the same kind of thing. They do give you a diagram. If you find it helpful to look at the diagram, like those triangles on the right, you can, but you might decide just writing out the congruent statement, kind of comparing point to point, makes a lot more sense. So whatever the case, go ahead and answer number 2, and there you go. All right, guys. So really quickly, just shout out the answers you got. So angle B corresponds to what? D. T corresponds to A. JD corresponds to CB. And BC corresponds to DJ. All right. And, of course, now we're saying that those elements are all congruent to each other. And we know that because we have the congruent statement. Sorry, I have the screen frozen. You can't even see what I'm writing. There you are. So let's look at the next part. This is where it all comes together, writing the correct angle or triangle congruent statement. Okay, and you can see that right there. In fact, I'll go ahead and highlight that. You can underline it. So the triangle congruent statement is a really key idea. So triangle ABC is congruent to some triangle. They don't give us the diagram. You'll typically have the diagram, and so it'll be pretty easy. But in this case, let's kind of figure out what's going on. I'm going to draw 2 triangles that are congruent. And it doesn't really matter for our purposes what the diagram is supposed to look like. We just need to have 2 congruent triangles. And I know the first one is triangle ABC. So I'm going to label my sides A, B, and C. I need to figure out what the points are on the other triangle. It says that AB is congruent to AL. So which points are going to be labeled what? Top left is A, and where's L? Bottom left. All right. Again, it doesn't matter where I labeled to begin with, as long as I'm kind of keeping things corresponding. All right, the next one says CA is congruent to GA, so CA is congruent to GA. You guys agree that G should be there? Okay, so if triangle ABC is one of them, what would the other one have to be called? ALG. Okay, you guys are getting the hang of it. If this is 100% there, you got it. This is as difficult as it gets. Okay. So the last little bit, and this is what we'll end class with. I'll go through the first one with you. Let me go ahead and tell you this one right here, where it says KR. This one requires using Pythagorean theorem. If you don't remember that, then don't worry about it. But if you remember it, go ahead and try and solve it. So anyways, they give us a triangle congruent statement, and we're going to go ahead and find the angle measures or side lengths based on that information. So triangle ABC is congruent to triangle TDJ, and I actually find it easier a lot of times to go back to the congruent statement like I was saying before. So anyways, C, what does that correspond to? J. And we're looking at the first one, so we want to know the measure of angle C. Well, that's the same as the measure of angle J. So what is the answer going to be? 50. So a lot of these don't require calculations. It just requires finding the correspondence. TJ, notice whenever it doesn't have the line over it, they're saying what is the distance from T to J. So TJ, I'll go up to the statement. TJ corresponds to what? AC. So let's find the distance from A to C is what?
4.7.
There we go. It's going to be 4.7 centimeters. I'm going to skip the measure of angle B and come back to it. So let's do AB real quick. AB corresponds to TD. What's the distance from T to D? 4.2. All right, so pretty straightforward. The last one, measure of angle B. What does that correspond to? D. We don't know either of them, but luckily,
A and C.
yeah, there you go. Yeah, we already found C in the first one, so you guys are seeing it. So we already know that this one's 50. So in this case, we're actually not using correspondence as much as we're using what? Triangle sum theorem. So do triangle sum theorem and tell me what B is going to be. 60 degrees. Okay, so you guys have 7 more to do, 8 if you want to do the Pythagorean theorem. And just finish that much out. If you want to try number 5 with the transformations at the bottom, you can do that too. But just finish these out, and then on Tuesday when we come back, we'll start actually writing proofs.